Think about the last time you filled up your car. You probably didn't think about it at all. You pulled up, you pumped, you waited somewhere between 2 and 5 minutes, and you drove away. It's such a normal part of life that almost nobody questions it. But that small window of time, call it 3 minutes, give or take, is actually one of the most stubborn bottlenecks in the entire history of personal transportation. For more than a century, the fastest way to put energy into a vehicle has been the same: a nozzle, a tank, and a weight. Now picture something different. You pull into a station that looks a little like a car wash. Sensors line you up, a platform lowers your car a few inches, and in less time than it takes to read the sentence out loud, a robotic arm underneath has already unbolted a battery pack the size of a mattress, slid it out, and slid a fully charged one back in. You never got out of your seat. That is not a concept video. That is a real process, running right now on real roads thousands of times a day. But here's the part most people never hear about. The reason gas stations have barely changed in 100 years isn't because nobody tried to improve them. It's because liquid fuel has one enormous advantage: energy density. You can move through a hose in minutes. Batteries never had that shortcut. Charging an EV means waiting for chemistry to happen. Ions moving slowly through a cell, generating heat the whole time. Push that process too fast, and you risk degrading the battery, or worse, triggering the kind of thermal runaway that's made headlines in parking garages and residential buildings. So for years, the entire EV industry accepted a trade-off. Charging would just have to be slower than fueling permanently, full stop. That trade-off is now being challenged, not by making batteries charge faster, but by skipping the charging step entirely at the point of use. In late 2025 and into 2026, Chinese battery giant KTL began rolling out a swap system called Choco SEB, alongside expanding networks from NIO, on a scale nobody in the West has attempted. If you find it fascinating when a boring, overlooked piece of everyday infrastructure quietly gets reinvented, this is exactly the kind of story this channel covers. So hit like and subscribe so you don't miss the next one. Here's the thing worth sitting with before we go further. This idea isn't new. Tesla actually built and demonstrated a battery swap station back in 2013. Elon Musk stood on a stage and swapped a Model S battery in about 90 seconds, faster than filling a gas tank, and the crowd loved it. Then Tesla quietly shelved the entire program. Why nobody fixed this sooner is really a question of why Tesla walked away from something that worked. The answer wasn't that the technology failed, it was that the business case didn't. A swap station requires an expensive standing inventory of charged batteries sitting idle waiting for the next car. That's capital tied up in a warehouse of expensive lithium cells instead of moving. It also requires every participating car to use the exact same battery shape, size, and mounting points. Otherwise, the robot underneath the car has nothing to grab onto. Tesla, like most automakers, redesigns its battery packs every few years to squeeze out more range and efficiency. A pack that's swappable is a pack that's harder to change and harder to integrate into the floor of the car as a structural element, which is exactly what modern EV design wants to do for weight and safety reasons. So Tesla made a rational bet: build a bigger, faster charging network instead, and let the battery evolve freely without being locked into a fixed shape. For most of the world, that bet looked like the right one. Charging networks did scale. Fast charging speeds did improve. But China took a different path, partly because of geography and partly because of who was buying EVs first. Dense cities, millions of drivers without access to home charging or a private garage, taxi and ride-hailing fleets that needed to stay on the road, not sit at a plug for half an hour. In that environment, the old trade-off flipped. Suddenly, the standing cost of a battery inventory looked less like a liability and more like infrastructure. The same logic as keeping a warehouse of propane tanks ready to swap at a hardware store, just built for a car instead of a grill. The company that leaned into this hardest was NIO. The mechanism behind a modern swap station is deceptively simple to describe and genuinely difficult to engineer. A car equipped for swapping doesn't bolt its battery to the chassis with dozens of individual fasteners the way a normal EV does. Instead, the pack sits in a standardized cradle locked in place by a small number of points, usually 4, that a robotic system underneath the station can reach, unlock, and release in sequence. When you pull in, cameras and sensors first confirm your car's exact position, sometimes correcting it by inches using the vehicle's own steering. The station's platform then rises to meet the underside of the car, unlocks the depleted pack, lowers it into the building, and simultaneously lifts a fully charged pack up into the same cradle, locking it back into place. NIO's most recent generation of stations completes that whole sequence in around 3 minutes from the moment the car stops moving. KTL's Choco SEB system, built around a smaller standardized chocolate bar style pack shared across multiple partner automakers, has pushed that down further, with the company demonstrating swaps completed in roughly 70 to 100 seconds under normal operating conditions. To put that in perspective, That's faster than the 2 to 5 minutes most drivers spend standing at a gas pump. And it happens without you ever leaving the driver's seat. The batteries that come out aren't scrapped or degraded faster because of this. They're charged inside the station at a slow, controlled rate in a temperature-managed environment, which several manufacturers argue is actually gentler on battery chemistry than the fast public charging most EV owners rely on. TATL has reported that its latest fast-charging cells retain more than 90% of their capacity after 1,000 full charge cycles under this kind of controlled charging regime. A meaningful number in an industry where battery degradation is one of the biggest hidden costs of EV ownership. There's a mechanical detail worth pausing on, because it's the part that actually makes this safe rather than just fast. Think of it less like unplugging a phone charger and more like a pit crew changing a race car's tires, except the tire weighs several hundred kilograms and has to seat into an electrical connection precise enough to carry hundreds of amps without arcing. The locking points aren't just physical latches. They're paired with sensors that confirm electrical contact, thermal state, and structural seating before the car is even allowed to release its parking brake and drive off. If any one of those checks fails, the station simply won't release the vehicle, which is part of why swap networks report success rates north of 99%. The system is built to fail safe, not fail fast. None of this works, though, without one unglamorous requirement: standardization. Every swappable battery in a given network has to share the same dimensions, the same connector layout, the same mounting geometry, regardless of which car it's going into. That's the piece Tesla never solved, and honestly, never tried to solve at scale. It's also the piece China's battery makers have spent the last few years quietly building consensus around. The steel challenger nobody saw coming in this story isn't another battery chemistry. It's the idea of the battery as a shared, swappable commodity instead of a component locked to one car. KTL, the largest battery manufacturer in the world by a wide margin, made a strategic decision that instead of competing only on cell chemistry, it would also compete on the swap infrastructure itself, opening its standardized pack design to multiple Chinese automakers rather than keeping it exclusive to one brand the way NIO originally did. That single decision changes the economics of the entire industry. A gas station works because any car can use any pump. A swap station only works the same way if any compatible car can use any battery. CATL's Choco SCEB pack has already been adopted by taxi fleets in Chongqing, where the company had established dozens of swap stations by early 2026, each capable of holding around 30 charged batteries ready to go at any moment. The vehicle using this system is deliberately unglamorous, a Chang'an Ocean sedan priced around $23,000, proving the point that this isn't a luxury feature reserved for flagship cars. It's infrastructure meant to work for an ordinary taxi driver doing back-to-back shifts. CATL didn't stop at passenger cars either. In the Greater Bay Area, the company partnered with a logistics operator to put standardized battery swap light trucks into commercial delivery operation, with plans to scale that fleet into the thousands by the end of 2026. Because a truck that spends less time charging and more time delivering is a truck that pays for itself faster. Meanwhile, NIO, the company that pioneered this entire approach back in 2018, has been building out its own network for years, and by mid-2026 had opened roughly 9,000 charging and swap stations across China, having completed more than 100 million individual battery swaps since its very first station opened in Shenzhen. 100 million is not a pilot program. That's a number that only shows up when something has quietly become part of daily infrastructure. The same way nobody remarks on gas stations existing, they just expect them to be there. The world starts copying whenever a Chinese infrastructure bet stops looking experimental and starts looking inevitable, and that shift is already underway here. NIO has been expanding its swap network into Europe, aiming to grow from roughly 30 stations to more than 500 across the continent by the end of 2026, entering new countries as it goes. Geely, one of China's largest automakers, has partnered with NIO to build compatible swap-ready vehicles rather than compete with an entirely separate standard. FAW, one of China's oldest state-linked automakers, has joined the same standardization effort. CATL, for its part, has partnered with the logistics sector directly, working with delivery and freight operators to deploy thousands of standardized swap-ready light trucks, aiming to prove the model works for commercial fleets, not just passenger cars. Battery swapping, as a power replenishment method, has already become very mainstream, one NIO executive said, describing the milestone of 100 million completed swaps as proof the model had moved past the experimental stage. Even in the United States, where Tesla walked away from this exact idea over a decade ago, industry analysts have started re-examining battery swapping specifically for electric trucking, where long charging times are a much bigger operational problem than they are for passenger cars. It's a quiet kind of validation, Not a headline announcement, but engineers and fleet operators in the same country that invented and abandoned this idea now taking a second look, specifically because China proved the reliability numbers hold up at scale. Inside China, the expansion isn't limited to NIO's main brand either. Its lower-cost Onvo sub-brand is targeting more than 3,300 compatible swap stations by the end of 2026, up from under 2,500 just months earlier, showing the model scaling down market, not just staying a premium feature. The proof point that matters most here isn't a single flashy demonstration. It's the boring, repeated, monitored data. In February 2026, China's swap network hit a single-day record of more than 146,000 battery swaps completed nationwide in 24 hours, according to industry reporting on the country's charging infrastructure. NIO's own published figures show its network has saved drivers a combined total of more than 83 million hours that would otherwise have been spent waiting at a charger. KTL's Choco SEB stations, built for its taxi fleet rollout in Chongqing, are specified to hit a swap success rate above 99.9%, the kind of reliability number you'd expect from an airline safety metric, not a car accessory. And on the battery health side, the numbers being reported after real-world testing, capacity retention above 90% after 1,000 cycles, are being verified by the same companies whose reputations depend on those numbers holding up under public scrutiny, not just marketing claims made once and never checked again. So how big could this actually get? If swap infrastructure scales the way China's charging network has, the impact isn't really about shaving a few minutes off a single errand. It's about decoupling EV range anxiety from EV adoption entirely. Every argument against electric vehicles that centers on, "I don't have time to wait for a charge," quietly disappears if a full battery swap takes less time than paying for gas. It also changes how power grids handle EVs, because a swap station can choose to slow charge its inventory of batteries overnight during low demand hours, rather than every driver in a neighborhood plugging in at 6 p.m. simultaneously and straining local infrastructure. At the scale NEO and CATL are now targeting, a combined total approaching 10,000 stations in China alone by the end of 2026, swap networks start to function less like a novelty and more like a second parallel power grid built specifically for transportation. None of that means this becomes the default everywhere, and it's worth being honest about why. The single biggest barrier is standardization, and it's not solved globally, or even nationally outside of China. Every automaker that wants to participate has to agree to build cars around a shared battery shape, shared mounting points, and shared software, which means giving up some competitive differentiation, something most car companies have historically been reluctant to do. The upfront capital cost is enormous. Each station needs a standing inventory of charged batteries, and NIO's total investment in its swap network has run into the billions of dollars, a bet that's only paid off because the Chinese EV market is large enough and dense enough to make station utilization high. That density argument cuts against adoption in places like rural America or much of Europe, where population and EV ownership are spread out enough that a swap station might sit half idle for most of the day. There's also a real gap between wealthy, urban markets and everywhere else. The same way fast charging networks concentrated in cities first and took years to reach smaller towns, swap networks are likely to follow the same uneven pattern, arriving in dense Chinese and European cities long before they arrive in lower density regions. And regulatory approval, especially in the United States and the European Union, moves slowly by design, meaning even a technically proven system can take years to clear the safety and infrastructure review process needed to operate at scale in a new country. None of that is a reason to doubt the engineering. It's the gap between what's technically possible right now and what will realistically exist on every street corner a decade from now. Which brings us back to where we started, that 3 to 5 minute stretch of time you spend at a gas pump without a second thought. It turns out that small, boring window of time was never really about fuel. It was about the fact that energy, however you store it, still has to move from one place to another, and someone has to solve the unglamorous engineering problem of doing that quickly, safely, and at a scale of millions of vehicles a day. China didn't invent electric cars, and it didn't invent the idea of swapping a battery. Tesla demonstrated that over a decade ago on a stage in California. What changed is that an entire industry decided the economics were finally worth it, and then built the standardized infrastructure to prove it at a scale nobody else has attempted. If an idea a major automaker tested, filmed, and then walked away from over a decade ago is now running 100 million times over on the other side of the world, hit subscribe so you don't miss what gets rediscovered next. And here's the question worth sitting with. If battery swapping was sitting in plain sight since 2013, dismissed as impractical by the company that invented it, what other failed ideas from the last decade of EV engineering do you think just needed the right market and the right scale to actually work?